coming to the next part, we will see isoelectronic species. What is isoelectronic species? I have told you earlier. The species having the same number of electrons are known as isoelectronic species. Now, species means what? Species can be neutral atoms. It can be positively charged ions, that is cation. It can be anion. So, neutral atoms or cations or anions having the same number of electrons in it are called as isoelectronic species or isoelectronic ions, so to say. Now, the question is not this. The question is here. When an isoelectronic species is given, when a group is being given to you, and you are being asked to arrange in the increasing or decreasing order of its atomic radius, how will you do? How will you find it out? That in case of isoelectronic species, which is the biggest one, which is the smallest species, how will you find it out? That is what I am going to say you now. Got it? So, for example, the isoelectronic species, I am writing it here. Let us say I am writing it here Mg2 plus, then Na plus, then Al3 plus, then let us say F minus, then O2 minus and Ne. Got it? Count it. Mg is having 12 electrons. 2 plus means 10. Again, Na is having 11. Neutral Na, all this neutral I am saying, neutral is 11. Got it? Neutral Na. It is having 1 plus means 1 electron less, so 10. Neutral aluminium 13, so 3 less means 10. F minus, F is having 9, so 1 more means 10. O2 minus, same thing 10 because 8 atomic number, 2 minus, Na is neutral 10. Got it? So all are isoelectronic species. So E, let me write it as, let me write first Z. Z is here 12, here 11, here it is 13, here it is 9, here it is 8 and here it is 10. And E, that is E, the value of E is same because isoelectronic means it has got same number of electrons. Fine. Now, to find it out the atomic size, what I need to do? I need to find value of Z by E. Z by E. So 12 by 10, 1.2. It is 1.1. It is 1.3. It is 9 by 10, 0.9, 0.8 and it is 1. Now, why did I find Z by E? Note it down. Smaller the value of Z by E, larger is its atomic radius. Smaller the value of Z by E, larger is its atomic radius. Means that species is larger. It is bigger in size. So here what I said, smaller the value of Z by E. So which is smaller here? 0.8. So this is the maximum size. This one is having the maximum size. And which is having the minimum size? This is having the minimum size. Because what I said, smaller the value of Z by E, larger is its atomic size. So if I ask you to arrange in increasing order of atomic radius, increasing order means chota sa bada. Alright, from smaller to bigger. So what I said, smaller the value of Z by E, larger is its atomic radius. Alright, what I said here, larger. So hence, which is the larger here? Oxygen. Then which is the smaller here? That is nothing but this. I asked you to arrange the increasing order, means smaller to bigger. That means I have to see from 1.3. That means that is Al3 plus. Then after that we'll come to 1.2, that is Mg2 plus. Then after that I'll come to 1.1, that is Na plus. Then after that I'll come to, that is 1, that is Ne. After that I'll come to 0.9, that is F minus. After that I'm going to come to O2 minus, the last one is 0.8. This is your increasing order of atomic radius here. Increasing order of atomic radius. Increasing order, we can say that. Clear? Which I have done it here. Understood? What is the use of isoelectronic species? It is being used to, what you can say, find out the atomic size, to compare the atomic size. Now you may ask me if it is not isoelectronic species. If it is not isoelectronic species, then the question will be set accordingly so that you can come to know that which element is bigger, which is smaller, according to the group will be given and something will be given. Don't think that if nothing is given and the question is asked, that is not possible. Then that is a vague question. It's an incorrect question, so to say. Alright, now next, I am going to come to the next periodic properties. One periodic properties I have already covered with you. I have finished. That is your atomic radius we have done. Under that we have done the covalent radius, van der Waals radius, metallic radius, ionic radius, that is cationic, anionic, and so many things. We have compared it, we have learned it, we have seen it. Clear? Now the next is your ionization energy or ionization enthalpy, so to say. Ionization energy or ionization enthalpy. You have studied in lower classes, but still then I will say you. But of course, what we are going to study now, that much you have not studied. Now what is ionization energy? or annihilation enthalpy. You have studied the definition. It is the minimum amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. What I said? It's a minimum amount of energy required to remove an electron. Here you can say remove a loosely bound electron. That also you can add it the word. Why? Because the electrons in the outermost shell is loosely bound. They are known as free electrons because they are far away from the nucleus. If their nuclear forces is the minimum, you know it. Got it? Energy is all zero. Hypothetically is taken to be a zero. Arbitrarily is taken to be zero. All these things you have learned it in the previous, what you can say, classes in the previous chapter. You have learned it. So hence, the amount of energy required to remove a loosely bound electron from the outermost shell of an isolated gaseous atom. Now, why do we say isolated? Because if an atom is free, it is not bound to any other atom, and if it is gaseous, you know, if it is a gas means the atoms are far apart from one another, then only it will be free. Got it? And if it is free, then it will be easy for you to remove an electron from the outermost shell. For that reason we say isolated gaseous atom. Isolated means one. Lonely, you can say lonely means here it is, it's not lonely word is here. Here we will use the word, it is free. Got it? It is not in the combined state, it is in free, that atom is. Got it? And how it is free? Because it is in the gaseous state. So everywhere you will find this particular word is there, isolated gaseous atom, isolated. Why it is? Because in the gas, the intermolecular force of attraction is minimum because the atom is at maximum distance from one from the other. So hence you can say it is isolated. Got it? Clear? Fine. So in this way, there is amount of energy required, again I repeat, required. That means it is positive. It is endothermic. Got it? So here you can see the value of ionization energy will be positive because I am saying required amount of energy which is required to remove an electron or loosely bound electron from the outermost shell of an isolated gaseous atom to convert it into its cation, because if you remove an electron means it will become positively charged, it will become a cation. Got it? Fine. So now this is called ionization energy or ionization enthalpy. This is a definition I have explained to you. Now next is, that is, what is the unit by which we measure the ionization energy? Generally the unit is electron volt, or you can say kilojoules per mole, or you can say kilocalories per mole. Any of the unit you can say that. This is SI unit and these two are the other units we can say. Clear? So in any unit it can be measured. Generally we use this particular one, electron volt, and it is positive. Mind it, I said you already. It is endothermic. It is the amount of energy required, I said. Follow it? Fine. Now next is after that. So what is successive ionization energy? Successive means one after another. Suppose you have removed one electron, then the second electron, then the third electron. That is called successive ionization energy. And always remember that successive ionization energy increases. Listen carefully here. Successive ionization energy increases. Why? Got it? That means I mean to say that is IE1, the first ionization energy, then IE2, the second ionization energy, then IE3, the third ionization energy. So ionization energy is increasing. The successive ionization energy increases. You can say that. Clear? The first ionization energy is less than the second, then the third. You can say that. It increases. Now why? Why it is so? I'll give an example and I'll explain you. See. Now let us say we are having an element that is, let us say magnesium is there. Let us say an element magnesium. Mg atomic number 12. Let me write the electronic configuration. 1s2, 2s2. 2p6, 3s2, we can say that. So in the outermost shell we are having 2 electrons. Let us say I am removing the first electron now, first. Alright, so it forms Mg plus, isn't it? So what is the electronic configuration now? 1s2, 2s2, 2p6, 3s1. 3s1 in the outermost shell, how many electrons is there? 1. So total number of electrons how many? 6 plus 4, 10 and 1, 11. But total number of protons is here 12 only. Here the total number of electrons is 12 and protons is also 12 in the first case, in the neutral state. Electron is 12, protons is 12. But when you have removed one electron, electrons is 11, protons is 12. So what happens? When the proton is increasing, nuclear charge increases. Nuclear charge increases. If nuclear charge will increase, the remaining electrons which is present in the outermost shell will be strongly attracted by the nucleus or weakly attracted by the nucleus. Definitely it will be strongly pulled by the nucleus. Got it? Clear? Definitely it will be strongly pulled by the nucleus. So it will be strongly pulled by the nucleus. Listen carefully. Will it be easier for you to remove this particular electron which is present in the outermost shell now? Because Here what happens is that atomic size is decreasing because nuclear charge is increasing. You see, number of protons is more, nuclear charge will increase. So the nuclear charge will pull the the remaining electrons, strongly towards itself. So the pull is very strong. So definitely you have to apply a stronger pull to remove that particular electron. That means to say you have to give more energy, then only this electron will be removed. What I said, you have to give more energy. So here the energy required is what? That is nothing but here this, when you remove an electron, this is the first ionization energy. Now if you want to remove the second electron, this particular electron, then what will happen? You have to give more energy to it, because just now I explained you. See, in the neutral state we are having this, you are removing one electron. Okay, you got ionization energy. Fine. Now you want to remove this also. You want to remove this electron now. So when you want to remove this electron, what it will be? Mg2 plus. So what is the electronic configuration now? 1s2, 2s2, 2p6. This is removed. Now electrons is how many? 10. Protons is still 12. See, nuclear charge still increases. It pulls more strongly towards itself. Due to which, what happens is that you require more energy to remove the electrons. So hence, for that reason, successive ionization energy increases. I hope you got it this. I hope you got. That is, when you remove an electron, you require some energy. That is the first ionization energy. Then when you remove another electron, that is second ionization energy. Why it is more? Because the nuclear charge is increasing. Due to which the remaining electrons is strongly pulled by the nucleus. To overcome this pull, you have to give some more energy. Then only you can remove that particular electron. So due to which the successive ionization energy increases. Fine. Now next you remember it. In this way, if you want to remove the third, it will be still more, we can say that. Now here you can see one thing I want to explain you. Here it attains electronic configuration of a nearest noble gas. Whose? It is nothing but that of neon. See here, 6 4 10. Clear? And in inert gases, the ionization energy is maximum. In a particular period, remember it is maximum. You know that when you move from left to right across a period, you have read it in the lower classes. Ionization energy increases. And down the group it decreases. Why across the period increases? Because across the period, what I said you just now, nuclear charge increases. Due to which more energy is required to remove an electron. So hence when you move from left to right across a period, ionization energy increases. When you move from left to right across a period, ionization energy increases. Understood why it increases? Because across a period, the nuclear charge increases, atomic size decreases. So definitely to remove an electron from the outermost shell, as atomic size is decreasing, nuclear charge is increasing. It will be easy for you or difficult for you? Definitely difficult for you. So hence ionization energy increases when you move from left to right across a period. So which particular one element is having the highest ionization energy? Inert gas. Inert gas. Why? See here. Because outermost shell is fully filled. Why it is going to lose electron? Because inert gas has nothing but nothing to do with the loss or gain of electrons, because already it is stable, already is fully filled. So it neither loses electrons nor it gains electrons readily. Already is stable. So why it is going to lose? So hence it will not readily lose. You have to give energy to it. So you have to give a maximum amount of energy, because you have to overcome the force of repulsion. Here the electrons is going to repel one another because outermost shell is fully filled. Due to which atomic size slightly increases, little bit increases. You have read it in the atomic size. So hence you have to overcome that particular force. To overcome that force, a huge amount of energy is required. Then only you will be able to remove the electron. For that reason, when you move from left to right across the period, again I am saying ionization energy increases and maximum is that of the inert gas. So here the first ionization energy is some value, second ionization energy is some value. But the third ionization energy, now if you want to remove one electron from here, that means third ionization energy, it is a very much greater value. Means let us say if this is 700 electron volt and this is let us say 950 electron volt, second ionization, the third ionization energy may be 2000 electron volt. It may be more than that of double, we can say that, or more than 2000 also it is quite possible. Why? Because you have to overcome the force of repulsion, then only we will be able to remove that electron from it. So hence, repeatedly I am saying, when you move from left to right across a period, ionization energy increases because nuclear charge, what you can say, increases. Atomic size decreases. The maximum is that of inert gas and it is positive, mind it. Down the group, why it decreases? It decreases because down the group, the number of shells increases down the group. Number of shells is increasing. So when number of shell is increasing, you are moving away from the nucleus, the atomic size is increasing. So will it be easy for you or difficult for you to remove the electron from the outermost shell? Definitely you will say it is easier. Alright. Suppose in the first shell, the atomic size is this. When you are having 2 shells, the atomic size is increasing. When you are having 3 cells, atomic size still increases. Now tell me, in which case it will be easier? Definitely in this case. Because here you are moving far away from the nucleus. See the distance of the nucleus. Here it is far away from the nucleus. So definitely it is here it is easier. So down the group, ionization energy decreases because atomic size increases. One more thing I will tell you later on, this particular about it. So understood, successive ionization energy always increases. The reason I have said it to you, remember it, and across a period the maximum ionization energy is that of the noble gas or the inert gas. Okay, thank you.